Hello everyone and welcome back to another tutorial. In this one we are going to talk about linked list in JavaScript. We are going to see that visually, which is awesome, and then we are also going to see how to implement linked list in JavaScript itself. If you like the video at the end, make sure to press the thumbs up button, and also if you think that I'm doing a good job with the tutorials, feel free to subscribe and hang out with us. I stream on Twitch every Wednesday and Saturday, so you can always come there, hang out with the community and see me live coding cool stuff with JavaScript. Without further ado, let's get started. Alright, so the first thing that you need to do is that you need to clone this repository if you don't have it already. So you need to go to github.com/ahsanir/funwithjavascript, and here you can just copy the code from here, and then you can copy this, and then you need to open your terminal, and inside your terminal you can do git clone and then paste the URL, and this should essentially clone this repository into your machine. And once you have cloned your repository, you can easily open that in your favorite editor. I'm gonna use VS Code, and you need to make sure that you install the packages using the npm install command. So you need to open the terminal. You can do it by going to terminal and new terminal, or you can use your own terminal, it doesn't matter. Once you open this, you need to run npm install. I have already done that because you can see that I have the node modules folder here. Once you have done npm install, you can just run npm start, and you should be able to see the application running on localhost 8080. The branch for this tutorial, however, is going to be a different branch. So what you need to do is that you need to run this command called git checkout, and here you need to say link-list-start, and then you are going to jump to the linked list example that I have created for you. Before we actually jump into the code, I need to show you the final output. So we have this JS linked list visual example, which actually makes it much more easier to understand how this works. In a linked list, every item is connected to the next item, which means that if I need to push an item to linked list, let's say I am pushing the item 22 into the linked list, that would mean that this 22 is an item which is now pointing to its next item, which is nothing essentially. So it points to null. Let's say if I put another item like ABC here, now this linked list has two elements. One is 22 and second one is ABC. The head in a linked list is essentially where the current cursor is at. So when we start viewing the linked list, what happens is that you start with the head. The head essentially points to the first item. The first item has a pointer to the next item, and the next item has a pointer to the next item, and this goes on and on and on until the last item, which points to null. Imagine that there is an empty linked list, which means that there are no items within the linked list. Even then, a linked list has a head, which essentially points to something. The head essentially points to the next item, but if there are no items in a linked list, then the head points to null. We could also say that it points to undefined, but for our examples, we are just going to say that it points to null. Now let's imagine an example where we actually have items in the linked list. So this is an example where we have 4 items in the linked list, and a linked list is a list which has different nodes as items, and each node contains 2 different things. One is the value in that node, or you could say the element in that node, and the second is the pointer to the next item. As I said, the head always points to the first item, so you can see that the head has this pointer to this location. Let's say these boxes that we see here, these are the pointers to the locations, or these are the locations where these variables are stored. So the head by default points to the first item's location, which you can see that it's x12 here. This item has 2 things, the element and the pointer to the next location. So here you can see that it says 2d4, which is the location of this next node. So the next node ABC contains the pointer to the next node, which is this one, and then you can see that here the value is 33, but it also has a pointer 66z, which points to the location of the next node, which is DEF as an element, and it points to null, which means that this is the last item. So how do we identify different items at different places? We can easily say that the head always points to the first item, so we know that's the first item. And we can also say that the last item would always point to null and not another node. So if I want to just show them in a linear example, this is how this would look. The head points to the first item has its value and the pointer to next item. The next item points to the next item and has a value, and this goes on and on and on until the last item essentially null. When we are going to implement this in JavaScript, you will see the structure similar to this one. So just hold your horses and let's ride this journey of linked list. So as I said, you need to be on this branch called linked list start, and this is where we are going to start working on the project. So our project is already running, which means that we are running the npm start command, which is right now serving our code on localhost 8080. Let's quickly check this out. So I'm on my localhost 8080, and here you can see that we have this link called JS link list. And if I open this, we have a couple of buttons which actually do what we are going to implement in the link list. For instance, we can push items to the link list, which means that we are going to define an item, let's say 22, and this is going to push this into the link. Similarly, we are going to insert an item at a particular point or a particular index. Similarly, we are going to remove an element by giving the element itself. Let's say there is a node in the linked list that has a value of ABC. So if we give this value, then it should remove by finding that item and then removing from the link. Similarly, we can remove an item from a particular index. We can get a particular item at an index. So when we click this button, we can just provide the index, let's say 2, and then we should be able to see that item here. Similarly, we can find the index of a particular item. Let's say I can click this button and say ABC. So it's going to go and find out that particular item and will provide me the index of that item. And we also have some utility functions, like we can check the size of the linked list, which essentially tells us how many items are there in the linked list. We can also check if the link is empty or not, and we can clear the linked list by removing all of the items. And finally, we can also see the string version of this linked list. Right now, we are only going to add items as a string, which means that when we click this button, it's going to combine all of the linked list nodes items separated by comma. So let's begin with implementing the linked list in Java. So I'm quickly going to close this, but the server is still running. So I'm just going to minimize this. And inside the source folder, we have this JS linked list. Here we have the index.html. We have this linked list.js. This is the main file where we are going to be working on. Then we have the main.js, and we have UI handler. You don't need to worry about the UI handlers. This is something that I have created to make all of this visual so you can actually see how the link works. Now, let's talk about the linked list itself. As we said, each item in the linked list is going to be a node which contains the element as well as the pointer to the next item. So let's create a class for this. For this, we are going to just say class node, and here we are essentially going to say constructor, and this constructor is going to receive an element. So here we can say element. Then what we are going to say here is that we are going this dot element equals element, and here we are also going to this dot next equals to null. Now remember that when we add an item to a list, by default it's going to point the next item to null, which means that this could be the last item itself. Now also notice that we have this default equal function here. This is going to be used later in the code to compare when we are going to try to find an item by its index. Whenever we have to compare an element, this is what we are going to use. Now let's talk about the linked list itself. By default, as we said, that linked list has a head which points to null by default when the linked list is empty. So we are going to say head equals to null just to initialize. Now, whenever we create a linked list, there are some things that we need to consider. So we are going to create a constructor for this. And here we are going to say that this linked list is empty. So here we can say something like this dot head equals to null. Actually, I think we can remove this from here. Then we can say here that this dot count equals to 0, which means that we are keeping a count of how many items are there in the linked list. Finally, we are going to say this dot equals function equals default equal function, and this is the equals function which we are going to essentially use when we are comparing items. And this is something that someone can actually pass when creating the linked list. So here we can either use the function if that is passed, or we can use the default equal, and we can actually do this in a clear manner just like this. So we can say this, and here we can assign it with the equals function. Now, if a developer is trying to create a linked list using objects, then they can provide their own implementation of how to compare two different objects using their equal. Having said that, there are some functions that we need to create for this linked list, and they are actually directly proportional to the functionality that we have in our HTML, which is all the buttons that I just showed you. So I can quickly list down all of the buttons that we need to create. So these are all the functions that we need to create: the push function, the remove add, get element add, insert add, index of, remove, clear, size, and is empty, get head, and to string. The push method essentially would cover how do we add an item to this linked list. We are just going to provide the element, and this is going to push this element in the linked list right after the most recent item that we have. The head always points to the first item, push an element after the last item in the linked list, and you're going to see this right away. So how do we push an item into the linked list. First of all, we need to create a variable. We are going to say this is current, and then we need to iterate over this linked list in different scenarios. Let's say that there is no item currently in the linked list, which means that it would be a situation where this dot head would equal to null, which means that there is no element inside this linked list. In this case, all we need to do is that we just need to create a node and then assign the head to that node. So here what we can say is const node equals, and here we can say new node. So we are creating a new node here, and it's going to be this node actually. So we are using this linked list node class, or just the node class, and here we are going to provide this exact element that we need to create. Now that we have created this node, all we need to do is say this dot head equals node, and that's pretty much it. This node essentially is the pointer to this node that we have created, or the location where this variable now resides. Now if this is the case, we are good. But if that's not the case, which means that the linked list already had some items and this is not the first item, then we need to do a bit more. So in this case, we are going to create the else statement, and then we are going to say current equals this dot head, which means that we are first going to start from the head, which means that right now we are checking the first item, but now we are going to loop over all the items until we find the last item, and then we are going to push this element that we are pushing right after the last item. So for that, we need to do something like while. So we are going to run a while loop, and we are going to say current dot next not equals to null, which means that we are going to keep running this until we get the last item, and we are current equals current dot next. So we are just iterating over it. Once we are done with all the iterations and the final item has been received, which points to null, then all we need to do is say current dot next equals to node, which means that we are pointing the last item or the previously last item to this new node that we have created, and that kind of makes our link. Finally, when we have created this item, we also need to make sure that this count is not 0 anymore because we have added a new item. So here we can say this dot count plus plus, and once we are done with that, we can actually test this out. So I'm just going to write this as work. Now that I have saved this, let's try this out. But even before that, we need to make sure that we are using this functionality inside the UI handlers. I'm going to go to UI handlers, and here we need to make sure that we are using the link push that we are already using. All right, now that we have this functionality implemented, we also need to implement some more functions before we can test it out UI, because our UI handler right now depends on this size. So I need to go here and talk about the size. This size method essentially is going to identify how many items are there in this linked list, and they are dependent on this count. So here we can easily say return this dot count. We can also implement the isEmpty function here, which essentially would say return this dot size, it's equal to 0. So if it's 0, then it's empty, otherwise it's not. Now that we have implemented this, we can go to the browser and check this out. So I'm going to refresh my browser, and here we are going to say push, and here I'm going to say 22, and if I hit OK, you can see that quickly it comes here. Now you can see that the head now points to 22 instead of null. Let me repeat this again, but now with also using the Chrome DevTools. So I'm going to go to source, and I'm going to have this breakpoint here. And now let's see what happens when I click push and if I add some item. So let's say right now the linked list is empty. The head is pointing to null. If I say push and if I type ABC, click OK, let's see what happens. First of all, we get the element ABC. Then we create this node, which is right now element ABC, and the next is pointing to null, which is what the head right now is pointing to null because this linked list is empty. So now it goes forward, it assigns the head to node. So it will assign the head to the node, which is perfectly fine. And now it's going to increase the count without executing this other code, because that's obviously what we want. So here it's going to go ahead and then it renders the ABC word here. Now let's add another item to this linked list. So I'm going to say push, and here I'm going to say 22, and if I hit OK, let's see what happens. So in this case, we are going to create a new node, but now the head is pointing to the first element, which is ABC, so it's not null. So it's going to go to the next code. It's going to first say that the current is dot head. So here you can see that the current right now is the first item, and this item is pointing to null. So since this is already pointing to null, it's just going to go ahead, skip this whole and say current dot next, which is right now null, is set to the node, which means that we are pointing to the next item. The count is going to be plus plus, and we see the next item. Now the third time, if I add another thing here, now we are also going to run the while loop because it's not going to work otherwise. So here goes inside, it checks the current item. So it always starts with the head. So it's the first item that is E right now. See that it goes inside and and then it says current equals to current.next. So the current.next, or the first item, is ABC. Its next pointer is towards the item 22 that you can see here. Now it's going to run this first time, and now it's going to check, hey, is the new item that we've got, which is now 22, because we already looked at AB. Now the 22, is it pointing to null? And it's actually pointing to null, so it's going to skip this. The current item is 22 because the pointer is here now. So the current item is 22 and the next is null, so that's why it's going to assign the new item that we created, DEF, to this current.next, which is now going to be this. So you can see that the element 22 now points to the next node, which is DEF, and now you can see that this is happening right here. Now a fun part here is that even before we add something, I can show you how the linked list looks like right now. So let's say we have FE, that's something that I'm just going to add. So if I say okay, let's see what the linked list looks like. So here, if I say this is the linked list. If I open this, let's see how this looks like. First of all, the count so far is 3 because the fourth item is just about to be added, but so far it's 3, right? The head is pointing to the first item, which is ABC. If I open the head, see the element is ABC, but the next is pointing to the next item, which is 22. So here you can see that it's 22. If I open the next, that item also has a next property which points to DEF, and if I open that, you can see that the final item points to null. So you can see the exact same structure that we talked about inside our Miro code. It looks exactly like that. So in a linked list, every item that you see points to the next item and has a pointer to the next item until the last item, which points to null. So in that case, you now understand how a linked list works. Alright, now that we know about how the linked list works, let's talk about some other functions as well. So I'm really interested in identifying how do we get the index of a particular item which has already been pushed into the linked list. So what I'm going to do here is that first I'm going to go into main.js where we are actually creating our linked list, and I'm just going to hard code a couple of pushed items so we don't have to do that manually again and again. So here what I'm going to do is that I'm just going to say linked list dot push. Here I'm going to add 22, 33, and let's say some strings like ABC, and let's say X, Y. Now we have 4 items in the linked list. Let's check it out. So now if I refresh, see that we get 4 items that I just added. Now let's go back to the code, and now I'm going to go into the linked list.js, and here we are going to implement this function called index of element. So this function is supposed to receive the element that we are trying to find and return what is the index of this element in the linked list. Now understand this, that the first item that we create in the linked list that has the index 0, then we add another item, so that's index 1. So it kind of behaves like an array when it comes to talking about index, but essentially it's not generally an array, but we still can find the index of an element. And the reason for doing that is that we should be able to easily remove an item from a particular index, and that's how we are able to do that using this index of method. So how do we find the index of a particular element? First of all, we are going to start from the head, of course, and then we are going to iterate over the entire list until we find the element that is a matching element. And for that match, we are going to use this equals function that we have within the link. So here, I'm just gonna say we start this, or we can say let current equals this dot head. So we start from the, then we implement a for loop, I equals to 0, blah blah blah, and we would change some things here. So first of all, we need to make sure that we run this towards this dot size, or we could also say this dot count, but I'm going to use this dot size. And we also need to make sure that we end the loop when the current is null. So we can say current not equals to null, and then we do I plus plus, and then we are just going to check if this dot equals function. So we are comparing the values. So we are going to pass 2 values. First, the element that we are trying to find, which is this element that is passed in the index of. And then secondly, we also need to find the element at index I. So how do we get that? We essentially have that in the current variable. So here we can say current. So if the current dot element matches the element, then we can say, hey, this is the index that we are talking about. So here we can simply return the value I, that is the index. But let's say if we cannot find the index reason, then we are just going to say return -1, which means that we could not find the index itself. And whenever we run this loop, after each iteration, we obviously have to update this current. So here we are going to say current equals to current.next. So we always find the next item. Now let's try this functionality and actually see how this. So I'm going to refresh my browser and I'm going to go to this index of method, and here I'm going to put a breakpoint. And now we are going to find the index of this ABC value. So we can see that this is at the index 2 because we know that the index start from 0, 0, 1, 2. So I'm going to press this button index of, and now here it asks enter the element you want to find the index of. So I want to find the index of ABC. So I'm going to say ABC, and if I click OK, we get the element ABC here. Then we start the loop. So obviously we are going to start with the head. So the first current is right now 22. So you can see that this is the 20. Then we are going to start the loop itself. Then we are in the first iteration, we are trying to match element, which is ABC, that we are trying to search, with the current dot element, which is 20. Since they are not going to match, we are just going to say current equals to current dot next. So instead of 22, now we are going to work with 33, which is the next item. So then you can see in the loop, now we are trying to match ABC with 33, which is this one. So it will also not match. We will try the next one. Then it's going to try ABC versus ABC. And now this is going to match. Since it's going to match, we can easily see that this is now returning the value I, which is the index 2. So we know that the index of element AB is 2. That's how it should be working. Now let's try another value that is not in the list. I'm going to say index of here. I'm going to say weird here. And if I say okay, you will see that it will go inside. It will try to match it first time, the next item, the next item, the next item. Now this time it's trying to match it against XY, which is the last item. It will obviously not find it. And then it will finally return the value -1, which means that the element is not found in this linked list. So this is working perfectly fine as well. All right, let's implement another function now. I'm going to be implementing the get element at, because this is going to be the basis of some other function. So when I have to find the element instead of the index itself, then I can find the element by index using this function. So I won't have to know the element itself, but I would have to know the index in this case. So what I can do here is that first we need to make sure that the index is not out of bounds, which means that it's not less than 0 and it's not above size count. So here I'm going to say if the index is less than, or the index is greater than this dot count, or we could also use a size essentially, then in that particular case we are just going to say return, and then we can say undefined, say that not found at all. Now if that's not the case, then we can implement our logic. So how do we find an item by its index? So what we are going to do is that we are just going to loop over the items until this index, and then whatever item is found by then, we just return that. So here we can say let node equals this dot head. We could also say this current or node, doesn't matter. So let's use current since we are using here. So here, and we are going to run a for loop. So here we can say I, and I'm going to change this with I is less than index. And then we are also going to make sure that current is not equals to null, similar to, and once we are done with that, we need to make sure that it's going to be current equals current dot next. Now that we have done this, that means that we have iterated over all of the linked list items until the index has arrived. And now that we have that, we can simply return the current node which we have finally found. So let's save this, try this out and debug this. So I'm going to go to my browser and refresh now, and I'm going to just put a break. Let's say we want to find out what is at the index 3. So it's 0, 1, 2, 3. So I'm gonna call this function or click this button get element add. It asks me the index. So I'm gonna say 3. And if I click OK, let's see what happens. The index is 3 right now. The index not less than 0. It's not greater than the size. So it's not gonna go inside this block. Now we are going to say current is this dot head. So it's gonna take the head. So right now the current item is, so obviously we are going to loop over all of those until we get to this index. So see what happens. We see current dot next, current dot next, current dot next. So it happened 3 times. And now the current itself it's XY. And now since the current is actually equal to null, this is going to be stopped. And then here we can see the current item, which is XY. So here if I play this out, you can see that the element retrieved is XY. Now you could say that this was possible because of this null condition. So let's try something out, which is, let's say what has, so let's try something else, and then we can say what is at the index 1. So let's say get element at index 1. In this case, it's gonna go here, 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 and then you will see that it's going to say current dot next, but then the index here is 1 and the I is 0. So it's gonna be increasing, and now the I is 1 as well. So this is going to stop here. The current item is ABC, or actually 33, not ABC. So it gets the item which is at index 1, 33. Similarly, if I say what is at the index 2, it's going to return AB. So let's say index 2 here, forward, and you can see that it is AB right now. So this is working perfectly fine. Now let's implement another function which is remove at, and we need to identify, or we need to remove a particular item from a particular index from this link. In this case, let's quickly move towards the logic. It's going to check the same thing since it's based on index. So we need to make sure that not out of the bound. However, we need to make sure that the index can also be the count itself in this particular case. And I'm going to tell you why in a bit. Now we are going to say let current equals this dot head. Again, in order to use the remove functionality, we are going to do all exactly the same as what we did in the get element add. Essentially, we are actually going to use this function in this particular remove add method. So let's see what happens. First of all, if we need to remove an item from the index 0, then we don't have to do much. In that case, we are going to just check if the index equals to 0, which means that this is the first item that we can simply say this dot head equals current dot next. Now, how does that work exactly? Let's say we have a situation where we have these elements. We have, let's say 1, and then we have 2, and then we have 3. Now the head essentially is right now pointing to 1, right? And if I need to remove the value at index 0, or actually let's change these names, let's say A, B, and C. So in this case, if this is the first item and I need to remove this, the head right now is pointing to A. All I need to remove from this whole linked list, if I need to remove this, is just the head pointing to B. So if I just put the head to B, then that means that the A will be negligible in this case and will be removed. And that's what we are doing here. The head essentially by default points the first item, but we are saying, hey, don't point it to the first item, but actually take the first item's next property and point it to that, which means that we are going to remove that item automatically. Now, let's say if the index is not 0, then we have to do some shuffling because we need to make sure that we remove an item, still keep all the nodes in the link. Now, in that case, if we see the same example, let's say we got some items like this. So let's say we got an item like AB, CD, DE, F, and let's say XY. If we needed to remove CD from this point, then that would mean that AB will no longer point to CD. It will point to DEF. This is what we need to make sure that if we remove something from the middle, then these two are linked. Similarly, if we remove DEF, then that means that CD, which is currently pointing to DEF, now has to point to XY. So how do we do that? We are going to iterate over it and make sure that we fix these links or the broken links and still maintain the whole link. So in order to do so, what we need is that we are going to say const previous, because we need to find out what is the item that needs to be fixed. So here in this example again, so what we need to do here is that we are going to say const previous, and then here we need to find out what item is to be removed. Let's say DEF is the one that we need to remove. So we need to get this CD, the previous item. So in order to get that, we are going to say this dot get element add, and we are going to say index -1. Now understand this situation that we already know that we need to remove DEF, which is at index 2. So we know that we need this item, which is at index 1. This is what we are trying to do here. So we are saying that, hey, remove an item at index 2, but first get the item at index 1, which is 2 minus. So once we get that item, we are going to say current equals previous dot next. And that means that we are essentially saying this situation. So this previous essentially is right now pointing to DEF. So we say, hey, this previous right now it's this item. The current that we have, which is this one, is essentially going to be previous dot next. Then we are going to say previous dot next equals to current dot next. So this current item that we need to remove is essentially this one. So we are saying, hey, this current, that's going to be removed. So the previous dot next is going to be this one, which is the current items next. So once we are done with this, we need to also say that this dot count minus minus, and then we need to return the current dot element. We just need to return what item was removed. So after all of this, we should have removed the item from the list. Now that we have implemented this, let's try this out. So I'm going to go to my browser and refresh, and now we are going to say let's remove an item from index 2, which is this ABC. We are going to say remove element add, and here I'm going to say index 2, and now you see that it came inside remove add index 2. So now it's going to take the current head, it's going to go here, it's going to find out the previous item, which is 33. So it's going to get that item. So you can see that the element here is 33. The current element or the 33 element right now points to ABC, which is to be removed, right? So what it does here is that it takes this current variable and it gets the previous dot next, which is ABC. So it takes it into this variable current. Okay. Now it's fixing this previous element's link or the next variable from pointing to ABC ABC to actually pointing to XYZ. So here's what's happening. So you can see that it says previous.next essentially should not point to current, but actually should point to current.next. So we are skipping ABC from here, and then this next is gonna be pointing to XYZ rather than ABC. So once we do this, see that previous, which is 33, now points to XYZ. So ABC is now out of this equation. The count was 4 before, we changed that to 3, and we return the element ABC that was removed. So if I play now, you can see that it says element removed, and if I click OK, you will see that this is going to be removed from the linked list, and now the 33 or the second item points to XYZ. Cool. Now let's move forward and talk about another function that is remove element. Now this one is pretty easy since we have got a lot of ground covered already. So how do we implement this? First of all, we need to just find the element's index, and then we can use this index function or remove at index to actually remove it. So it's actually a 2-line of code. So here we can simply say const index equals to, then we can say this dot index of element. So we are going to pass the element here. This is going to call the index of method, find the index, come back here, and then we can simply use the next line to remove this. So we can say this dot, or we can say return this dot remove at, and here we can say index, and that is easy peasy. So if I just save this, let's try this out. I'm gonna refresh now, and here now instead of just giving the index, we can actually give the element itself. So let's say we want to get rid of 33. What happens in this case? So here I'm just gonna go into this remove block, put a breakpoint. Let's say remove element. I'm gonna say 33 is the element that I want to remove from the linked list. I click OK. This first tries to get the index of element, so I'm gonna quickly go through this, and you can see that the index is found -1, which means that we have an issue, and the issue is because the linked list that we have has a number instead of the string. So let's fix that in the code now. So I'm going to go to my main.js, and here instead of these numbers, I'm going to use a string just for the sake of this tutorial. So I'm going to just say 22 and 33, save this, go back to my browser, refresh, and let's try this out again. So I'm going to refresh, I'm going to say remove element, here I'm going to say 33, and here I'm going to say okay. Now see what happens. So now since this is a string as well, it's going to take the index. Now you can see the index is 1, which means 0 1. So it found the index, and now it's going to just use the same thing. So it's going to take the index, go inside, try to find it, going to do previous next, all that magic, and if I hit play, you see that element removed and 33 has been removed. I can do the same thing again, just remove this, and now I can say, let's say remove XYZ. So I can say here XYZ, and if I click OK, you can see that it says element removed. Okay, that is all right. Now if I say something that is not part of the linked list, it also would say that this is not okay. So if I say okay here, you can see that it says element not found, and that is also working. Awesome. Let's implement more functions. So if I go to my linked list.js, there are some functions remaining. The important one is actually this one, the insert at, and this essentially allows us to add elements anywhere in the linked list just by providing an element and the index where we want to put this. Now this is going to be interesting. So first of all, we need to make sure that the index also is not out of bounds. So we are going to copy the same functionality from here, and then going to here, we have the same logic. So we need to make sure here is that it's not less than 0 and it's not greater than the size of the linked list. Once we are sure about that, let's actually implement the code. So we are inserting a new item at some index. So that means that we need a new node. So we can say const node equals new node. Here we are going to pass the element itself. Then we have two situations where we could add an item. First, it's the index 0, which is the easier one, and second, the index is not 0. So here we could say if the index equals 0, that means that we are adding this as the first item, although there could be multiple items already in the linked list, but we are adding at this index 0. So here we say const current equals this dot head. So we are adding, or we are getting the current item right now. Now what we'll do here is that we'll say node dot next equals to current. Because this node is now going to be at index 0, that node's next item becomes the current item that we have on the head. So let's say we have this situation where we have got a comment, and so let's say we have A, B, C, D, E, F, and X, Y. In this particular situation, let's say I wanted to add an item to here, which is index 0. So let's say if this was something like 11. So if I needed to add this item, what would happen in this? Currently, the head is pointing to ABC. If I add this item, the head is going to point to this 11 object. This 11 object is going to point to ABC. That's what we are doing here. So we have a node that we have created. This node now points to the current item, which was the previous head. So this ABC was the previous head, and now this new item is pointing to that, and the head itself should point to this new item, and that is the next line of code. So we can say this dot head equals to node. So that's what we did. I hope that this makes sense, and if it doesn't, let me know in the comment. Now if that's not the case, then we have a different situation, which means that the index is not 0 and we are using index greater than 0. So in this case we need to do some math. First of all, in this case, if I can put this again, which I always forget, so let's say we have 11, we have DEF, we have ABC here. Now let's say if I had to put another item between here, let's say have another item DDD. Now if I had to put another item like 22 between DEF and ABC, what would happen in that case? That would mean that currently DEF is pointing to ABC, right? Which means that if I add another item, DEF should point to that item and that item should point to ABC. That's what should happen. So there are two steps. First, find the previous item, make it point to the next item or the new item, and point the new items next to the next item in the linked list, which DEF was pointing to before. So that's what we are going to do. We are going to first take the previous item. So we are going to const previous equals, we're going to use the same logic that we did previously. Get element at index -1. So we're going to find the previous item just like this. Then we're going to say const current, and this current is going to be essentially previous dot next. So in the analogy where we are talking about adding this 22, this is what we have. So we found the previous item DEF, then we are finding the current item, which is previous dot next, which is ABC. So we got this into this variable, okay? Then we need to find this new node. We need to point this to this, which is current. So we are going to say here node dot next equals to current, which means that node dot next equals to current, and then previous dot next should point to node. So here we can say previous dot next equals node. All right, now since we are adding an item or inserting an item, this should be this dot count plus plus, and then we should do return true. Also here we have return undefined, but we could also say false, but I think that's fine. So now that we have this functionality, we can actually test this out. We're gonna go to our browser, refresh, and essentially just go ahead and put a breakpoint into insert at, which is right here. And now I'm going to say, hey, let's put another item between ABC and XYZ, which means that it is the index 2 where I want to put it, or actually index 3. So I need to put it right after ABC. So it's going to be 0, 1, 2, 3. So I'm going to say insert at, and here I'm going to say first the element that I want to add. So let's say the element is called DDD. Then the index itself is 3. So when it goes like this, we have got an error, and that says insert element add is not a function. Of course, we have a bug here. So I'm going to go to my code and try to find where that is set. So here we got insert element add. Maybe it's here, or maybe it's set here. So here it says insert element add. We can say insert. Now that we have this, let's fix this out. So I'm going to go to my code, refresh now, and let's see. So I'm going to do the same thing. We are going to say insert at. We're going to say the element is DDD. The index of this is going to be 3. It comes inside the insert at. The element is DDD. The index is 3. It goes forward, forward, forward. And here now we are doing the same thing. We need to put it here, which is around XYZ, just after the ABC. So we need to make sure that we get the ABC variable in the previous variable here. So here you can see that the previous dot element is ABC. So we got this element now. Now we also need to get this variable, which is previous dot next. So you can see that this is XYZ. So we get that in the current variable. Now, since we are adding an item between, we can say that the new item DDD is going to point to XYZ. So node, which is DDD dot next, is going to be pointed to current, which is right now weirdly different. So this previous dot next, it should essentially be current. It doesn't seem like it. So let's see. Yeah, it seems like there's some bug. So it seems like there was some bug in Chrome, or at least in the debugging, but this is working perfectly fine. So we got the node dot next pointing to XYZ, and the previous, which was right now ABC, is now going to point to the new node, which is DDD. So when we do this, we increase the count from 4 to 5, and you will see that the new item DDD is going to be pushed here in the middle. So if I play this out, you see that we got the DDD at this index. Now let's try this again. We're going to add another item between 33 and ABC, which means that we are going to add that to the index 2, 0, 1, 2. So let's say we add another item. We say insert at. First of all, let's say this item is Ahsan, and this is going to be added at the index 2. And once we do so, let's see what happens. So if I hit OK, here we go. So we added that between 33 and ABC and it works flawless. All right, let's see which functions are remaining. So I'm going to quickly remove these comments just to make things clear. So this comment, then there's this comment, and we're good. Now let's talk about the get head method. This essentially should just return this dot head. That's perfectly fine. We got the clear method. Now this is an important. How do we clear an entire linked list? The thing is that when we have a linked list that has nothing, you can notice that here the head is null and the count is 0. And essentially this is all that we need to do here. So we can go to the clear method and here we can say this dot head equals to null and the count is equal to 0. So let's try this out. So I'm gonna go here and refresh, and now if I just click this clear button, you can see that it says linked list cleared, and if I click OK, you see that there's nothing. The head right now is pointing to null. Super cool. Let's go back to the code. Now let's try to implement the toString method, which is an important one, which means that we just need to show all of the items in the linked list as a string. So this is an interest. How do we do this? First of all, we need to make sure that the linked list is not empty, and if it is, then we just return an empty string. So here we can say something like if this dot head points to null, that means that this is empty, or we could also have checked it using the isEmpty method. So actually let's try that. So we can say this dot is empty, this dot is empty, then we return just the empty string, just like this. Then let's do something else. So now all we need to do is construct a string. So here we can say something like const string, or we could say something like linked list string, and here we can say something like empty string, and then what we can do here is that we can say for. So we are going to run a loop of for, and here we are going to have this. Now the first thing is that we need to take the first item from the head, just like in any other function. So we can say const equals this dot, and here we can say something like for I equals to 0. Then we are going to run this loop into this dot size or less than this dot size, and we are going to make sure again that the current is not pointing to null. In that particular case, we are going to run the loop. Then what we need to do is that we need to construct the string here. So how do we construct the string here? We can simply say that linked list string plus equals to, so we are going to say plus equals to, and then we are going to say this, and then we are going to essentially add all the items. Now we could do this actually in two different ways. I think the easiest way would be essentially to create an array. So let's create an array. And then here we can say something like linked list string dot push, and here we can say something like, current dot element, and then in the next step we simply do a current equals current dot next. Once we do so, we will loop through all of these items, and in the end what we need to do is that we need to return the linked list string. Actually we can say something like linked list array, and then use that variable here, and then here we can join them using comma. Once we do so, we should actually get the toString method correctly working. So let's try this out in the browser. So here if I refresh, and let's say if we clear this whole array or linked list essentially, and then if I say linked list toString, you see that there's no output, or actually an empty string as an output. But let's refresh, and now if I click linked list toString, we get an error, and that's super cool because we get to fix that. So here let's go to toString and see what happens. So here if I click linked list toString, it checks this dot empty, then it goes forward, it checks this array, goes forward, and here we have the current dot element, so it pushes that, then we do current dot next, and in the end we got this error. So let's see what this says. So it says current is read only, which means that we are using const for current, and that is sad because we should have this as a let. So let's save this and try this out again. So if I refresh now, let's see what happens. So if I say now linked list toString, we get here, we go forward, we finally get the whole array of all the items that you can see, 22, 33, ABC and XYZ, all of these items. And then if I play this, you see that we get all the values by comma separated. I would rather have them as comma plus some spacing here as well. So let's do that. In my code, I'm just gonna go here and put a space here. That makes it a bit beautiful. So I'm just gonna put that here, make sure that we are not missing anything, and let's try this out in the browser. So if I refresh now, let's see what happens. So I'm gonna just say linked list dot toString. It goes here, play, and now you see that we get everything here comma separated in a really good manner. And that actually brings us to the end of the implementation for the linked list, and that is all I needed to teach you. Alright, so I hope that you liked the video. If you did, press the thumbs up button. If you want to be notified about the next videos, make sure to subscribe and follow the notify button. That will make sure that you get those notifications. If you think that there are some data structures or algorithms that I should be talking about, Write in the comments, let me know about those. And I stream on Twitch every Wednesday and Saturday, so make sure to come, hang out, see me live coding, and also give your valuable suggestions to me as well. If you think I'm doing a great job with these tutorials, you can support this channel by becoming a Patreon, so you can also see the link here. And as always, happy coding, and see this next video before you go around.